In this video, we will look at the portfolio selection problem in the text. The example considers an investment company, International City Trust. There's a table provided that gives us the investments, the interest earned, and a risk score, the data that we need to put together our investment strategy. As you read through the example, they want to maximize the interest earned, so this is a profit or interest earned maximization problem. They have an amount, 5 million, available for immediate investment that they want to use. They have this diversified portfolio of stocks in which they can invest, and they have some criterion. The criterion placed by the board of investors that no more than 25% of the total amount invested may be in any single type of investment. At least 30% of the funds invested must be in precious metals. At least 45% must be invested in trade credits and corporate bonds. The average risk score of the total investment must be 2 or less. Now that's going to be a little bit of a tricky one to put together, but we'll work that out. The table that we're provided shows us what it is we're buying, making, the type of stock in which we are investing, and we have the trade credits. Create a column for that. Corporate bonds, gold, platinum, mortgages, and construction loans. We'll have our solution row here when the problem is completed. It'll tell us how much money to invest in each one of these. I'll go ahead and make that yellow so you can follow it. We have the interest rate. We have, that is 0.07, 0.1. You can put this in percentage if you want. Just make sure that you get in here correctly with the decimals. Let's center all of these up. They're just a little bit easier to read if we do that. And then this will be our objective. Make that green so we can see the model take shape. Now we'll add our constraints. We have a total constraint, don't we? We only have $5 million to invest. So we have to count how many times we invest $1 in each one of these investments. And every time we invest in any of these, we'll count $1 against that total. And we have to make sure that's less than or equal to, and we were given 5 million. I'm going to format this column. In fact, I'll format this column. I need to see commas. You work with larger numbers, it's easy to make a mistake if you don't show the commas clearly. And I'll go ahead and use Control-C to copy that, and then I'm just going to paste that. Formatting, so I'll right click here and select Paste Special, and then just the format. Alright, got our commas. Now I'll make that. Use the format painter here, show you some different ways to format. Of course, we'll have to turn that green again. Now we got the commas in there. All right, let's look at the remaining criteria. We have a global criteria. We say we don't want any more than 25% in any single area. So we need to go ahead and create a max criteria for each of these. So we're going to have our max trade credits, max corporate bonds, max gold, max platinum, max mortgages, and max construction loans. And in this instance, we're going to use the total dollars invested at any time. Again, we could total these, but we'll just go ahead and look at our total. The total will always be here as well. So these are all going to be less than or equal to criteria. So let's set those so we don't get confused. And we're going to take equals 25% times whatever value is in this cell. And since they're all the same, I'm going to make that cell absolute, that reference, and I'll just copy this down. Now, once I've copied those down, I will go ahead and turn them on for each purchase. So when I buy a trade credit, I apply it against the trade credit maximum, same for corporate bonds, same for gold, the same for platinum, the same for mortgages, and the same for construction loans. And to make this a little easier, I'm going to go ahead and show the formula text reference for these calculated cell references, just so that you can see them on the screen as we work through our problem. This just shows you the formula that's in this cell. Each of these cells, it'll have nothing to do with our model. Now I have to put in the remaining constraints. We'll just work our way through the list. I like to do them in the order in which they're presented. At least 30% of the funds invested must be precious metals. So we have a precious metals constraint. And they're going to expect you to know that gold is a precious metal and platinum. So whenever we purchase either of those two, it's going to count against this constraint. And they want that to be at least, right? So greater than or equal to 30% of the funds invested. Again, 0.3 times, where are we keeping track of the funds invested? Right here. We do that. And again, our formula text reference is showing us the value that we placed in there. We look at the constraint list again, and we see that at least 45% must be invested in trade credits and corporate bonds. So we're going to have a minimum for trade credits and bonds. So every time we purchase a trade credit, we're going to count it against that constraint. Every time we purchase a bond, we're going to count it against that constraint. And it's at least, so it's greater than or equal to, and again, we'll take our 0.45, that's the constraint, and multiply it times our total investment, which is right here. Press enter, and you can see that value there. Now we come to our risk score constraint. The average risk score of the total investment must be 2 or less. So let's go ahead and put that in. We have risk score, maximum, and our risk scores are 1.7 for trade credits, 1.2 for bonds, 3.7 for gold, 2.4 for platinum, 2 for mortgages, and 2.9 for construction loans. And that is a maximum constraint, so we're going to make sure it stays less than or equal to a value. It's easier to explain how to construct this constraint if I show you the equation what the constraint is saying. So I have constructed the equation for this constraint and placed it here. Here's the less than or equal to, and here's the constraint, and here's the calculation for the cell reference to get the constraint. Now, this is going to be really hard for us to do in Excel. The reason it's difficult is Solver wants to place a value here. The formula says that I'm to calculate a value here. Now, I would prefer to calculate the values here. If I calculate a value here, Solver is just going to write over it, and I'm going to have a problem. So what I need to do is move part of this to this side of the equation. Well, we know that if this value over this equals 2, let's set it to equals, then this value has to equal 2 times this value. Now I have a calculation on this side of the operator, the less than or equal to sign, that I can put into my model. And that then would be 2 times, where am I keeping that total? You see it's T plus C plus G plus B plus M plus C. And this is where I'm keeping track of those. So I have this here. I press enter, and I'll show that there's the formula that I'm using. This formula then, this adjustment, satisfies this constraint. So now I can go ahead and construct my model and solve it. We'll put in some sum products. I have the solution set. We'll make that absolute, comma, the values to my left. Then sum product, the solution set, absolute, comma, the values to my left. And once I have those, I can copy them down. And I'll make those blue so you can see them, that they're calculated cells. I'm going to go ahead and make these blue as well, since they're calculated cells. Now I'll place my cursor on my objective, which is here in cell H6. Open select data. Go over here and select solver. All right. We have our objective, H6, that's good. This is a profit maximization problem, maximizing interest. We're going to do that by changing the values in the solution row, the yellow cells. And we have some constraints, so we'll add those constraints. I'll move this up here to make it a little more visual. I have some less than or equal to constraints right here, so I'll put the cell references for those constraints. Careful to end when they end, and then the constraint themselves. Then I will add some more constraints. I've got another less than or equal to constraint, so I'm going to add that again just again to illustrate that they don't have to be in a particular order. I'll put that constraint in. I have another set, so I'll add that. Here are the cell references for my greater than or equal to constraints. I'll change the sign to greater than or equal to. Here are the constraints themselves. No more to add, so I'll say OK. And I'll go ahead and make sure that my box is checked for unconstrained variables non-negative. Change this to simplex LP, and I will solve it. All right, solver gives us our solution. You can see the solution here. I'll go ahead and accept that solution and say OK. We can look down and see we have some binding constraints where there is no slack. There's a non-binding constraint, we have some slack. Again, a binding constraint, non-binding, non-binding, binding, 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 no slack. And that's how you solve the InterCityTrust investment problem in the text.